Who here of profile guided optimization? Okay, well, I'll give a refresher if you're not familiar, but for Go applications, starting in 1.20, the Go compiler allows you to take basically a profile of your code in production, and when you use that to compile your new program, the code paths that are active get faster, which is really cool, but the issue is it's not easy to get profiles from production. So my project is pairing an open source project that I'm a maintainer of called Pixie, which has these CPU profiles, and Dagger to do the CI part and basically integrate collecting, munging, and ultimately redeploying your faster application. So what does that look like? I created a diagram because I have a few of these pieces that are partially working, but the first step is you use the Pixie CLI to run what we call a pixel script, which basically will go out, find the profiles of your Go program, pull them down, and also your application binary. So this is a piece that would be running within Dagger or orchestrated by Dagger. From there, it will basically provide this pprof file and the binary, and the Dagger function is then going to take this pprof and turn it into a form that's profile guided optimization compatible. Essentially, the secret sauce for this, the piece that's missing is that each of these profiles to work for this optimization, you need to have the start line. And when you have the Go standard library available, this is really easy to do, but it's not easy to do if you're not written in Go. So that's why this Dagger integration piece makes it really, really handy. And so the idea is after the input file is annotated properly, we then export the file, which is now pgo compatible. And if I can slide over here. So coming out of that sort of step in the DAG, we would then get this output.pprof file that works with Go build, and we provide that to the compiler. You then get your faster Go binary, and you ultimately then can redeploy your application. Apologies, I can't seem to. Anyway, but that's the final step. And so by pairing Pixie, which is doing continuous profiling, and Dagger, which fits really well in this CI world and also has access to the Go standard library routines that we need, you basically can always deploy a optimized version of your Go application. Thank you.
Very cool. Awesome, that's super cool. Any questions? Please go see Dom. And oh wait, we got one quick one on the fly.
Is the module online somewhere?
Oh yeah, it's a module online.
I have not pushed my work in progress, but I can. So I can push that to GitHub and share it in the Discord, I guess.
Perfect.
Cool, I'll do that.
All right, well, hello everyone, my name's Sean Paul. I got funding a while ago from the governor's office to do some R&D on AI, but it kind of veered into working on like the psychological aspect of it, since a lot of people were a bit abrasive. And so this is like a previous demo that I made like somewhere else because I kind of like messed up with Dagger. But this was something from the mayor's office over in LA. And basically there was just some generic things that you could basically talk about, where you were from, what you do, and it basically just gave you some information. And so long story short, once you got that, then it would be able to send you to a platform to get your information basically like read by an AI, and it would basically say, okay, you can do X, Y, Z. And unfortunately, that demo also isn't working on me, as you can kind of see. But when it did, basically, you can use natural language to say, oh, hey, I need X, Y, Z. I don't know where to go. And it will basically comb through that data and give you the information you need. And so now, with some of the work I did with the governor, I ended up deciding to pivot and focus on people in the professional services industry. And so now I'm working on creating a tutor bot similar to what Emmanuel did. If any of you guys watched that tutorial before. I'm basically creating something somewhat similar to help people in the professional services industry to adopt AI, and it kind of acts as a bit of a black box / white glove tailored solution where it would explain what it's doing to the professionals when it comes to automating some things around their workflows. Since a lot of the things in like consulting or tax advising for accountants or legal advising, a lot of those things still have workflows that can be automated, but still have a lot of heavy personal touch. And I think through this approach, it can help to automate some things and explain the reasoning behind it, and also the return on investment. And so I'm doing some things like creating some service libraries for accountants, and I'm helping to automate the development of that. And that's sort of what I'm working on now, and that's what I plan to use Dagger for, because if the containerization can help to lower the failure rate of AI, that can help to make it a viable business use case, because even a 5% failure rate can cause much more than 5% of a business, especially if you need something like a lawyer or a tax accountant or even a consultant. There are still things that you would hold yourself accountable to if you can't deliver. And if your AI says, I'll sell you a Chevy for $1, no takesies, backsies legally, then you're going to be held to that, unfortunately. That's an actual case, funnily enough. Somebody did that to a chatbot. And yeah, that's kind of what I'm helping to prevent. And I want to try to involve other people as well in a community to try to make that happen. Yeah, that's why I like Dagger, because you guys are open source, and I think that's cool. So I'm failing forward, and I hope to meet you guys there. So yeah.
All right, who here has worked with log files? Really? What else the rest of you are doing? Who here finds log files super fun, especially at 2 a.m. in the night? Okay, yeah, so I thought maybe there is a more humane way of analyzing logs, considering we have artificial intelligence nowadays in our basements. So I created LogGPT, and Dagger made it really easy to do that. So here's a simple call. I have a whole bunch of logs in this file, and my user service is failing, so I got paged on that. So we'll run it, and Solomon, you owe me $5 for all the tokens so that you're wasting. Okay, so it's going to go through the logs, and there's a little bit of error that the user service is facing, mainly because there is a timeout somewhere in there. So hopefully it will grab everything and it will do the, while it does its work, let me just show you the simplicity of, I really like the simplicity of the Dagger approach here. Is this visible? People can read this? There's not that much going on. Yeah. So a little bit bigger, okay, well, this plus this thing as well. Okay, how about that? Okay, so here is the environment, right? In this environment, we are mounting the log file. So I just asked ChatGPT to generate some fake log file. That's what is in this one. And then we are passing in the prompt, which said like, hey, you are an expert debugger, so look at the log file and tell me what's going on. So it has already done all the good work, and you can see that it says, hey, the user service itself isn't what is having an issue. It's actually your notification service, which is croaking on the SMTP. Yeah, happens all the time. SMTP is still old school. Yeah, so there you go. You have LogGPT. Maybe I can enhance it over the Friday and start making billions. And I'll see you with Sam Altman next time. Thank you.
Okay. So I don't actually have anything to show because I broke the demo about 5 minutes before. But the idea was I'm traveling, visiting SF. So I figured I kind of wanted to make something that could help like plan travel itineraries. I like traveling. Sometimes it's a pain if you have to like plan everything and time everything. So the idea was to use Dagger alongside like a RAG database. So therefore, like when you call Dagger, it could, well, using Dagger, you could set up crawl the internet for various information like the parks, current pricing of things like flights and whatnot for hotels, and then using Dagger help basically pass that into a LLM like GPT, taking that input and then passing it back again to generate a prompt for something like Dolly or something Midjourney or something, or maybe not Midjourney, but like Dolly to create a like an image itinerary that you could then print out, save to a folder, and then like share amongst people. Very basic, but which is something that I personally thought I would want, and so I thought I would work on it. I got the GPT and the to like return and generate the prompt, but then trying to mess with Dolly kind of broke everything. Yeah.
That's really super cool. So like, I love the idea that you were like using Dagger to help you create a process for extracting the data you want, and then asking an LLM to actually write a prompt for you for another model that would be an image generation model. So very, very cool, multi-agent kind of a use case.
Yeah, I found that like at least especially the newer models for GPT are really good at, or at least good enough at generating the like very specific prompts for the projects example, and then tying in the RAG stuff just to make sure to keep it up to date. I know sometimes, like especially like something like Claude, I think it's like October 2024 was its last, what the train data goes up to. So you want to use that using the RAG database to help you keep up to date.
Very cool.
So I'm an infra engineer, so I manage Kubernetes clusters for people in my company. And one of the things they want to know is what happens to their application, right? And the number one way they figure out what happens to their application is by looking at log files, right? So what I do is I take their log files and I put it into an indexing engine like OpenSearch or Splunk. And one of the problems with a tool like OpenSearch, which AWS provides as a managed offering, is you need to provide the mapping of a particular log file, right? So here's an example. This is just a simple program. It has, a timestamp, it has a log level, and a log message, right? And in order for me to consume this log into OpenSearch, I need to tell OpenSearch, hey, there's a timestamp here, there's a log level here, and there's a message here, right? And OpenSearch wants a very specific configuration in order to actually be able to parse this, so my engineers can go and search whenever there's an error in the logs, right? So what I did was I used Dagger to build a function that grabs a log file, very similar to the previous demo, goes ahead and I wish I knew about the LLM keyword. I wouldn't have written like a crappy Python script. But if you look here, I essentially grab that log file, I send it to Claude, and I say, generate me a mapping, right? And I take that mapping, and right now I'm just writing it to disk in the container. But if you cat mappings.json, you'll see that this is now an OpenSearch configuration. It grabs a date. I swear it looked better previously, but message and log level, right? So it's generating an OpenSearch mapping for me from the log file I'm giving it. So ideally, if I had more time, I would have a Dagger function that inspects logs from a running process or my Kubernetes cluster, passes it out to this function that generates the OpenSearch mapping, and then I have another Dagger function that uploads that mapping onto OpenSearch, so it's easier for my engineers to search for errors. That's it. Thank you.
All right, good afternoon, everybody. My name is Brandon. This is Team Preplands. And essentially what we're doing is building an agent that takes a course material and breaks it down, analyzes the material, and then asks you questions to increase your understanding of that material.
So it basically, I think we went a bit too complex, so our demo is not fully functioning. But the first part is we need to load the PDFs. So let's say you have a class on AI, you load your AI class course there. Then we need to call one AI agent that is going to ingest the material and then based on that, understand it and start asking you questions. Then the other agents that, based on whether the answers are correct or incorrect, is going to keep asking questions on either like more complex topic or start having going at a easier level. And then a third agent that would then ask to just summarize and give a report on what's working well, what's not. ideally we even had a fourth one that we did not implement, that would then build and create a video that would give you material, like video material on these are the topics you don't master. Here's a video for you to learn about it. So yeah, that's a global idea.
Yeah, this demo is not working, but I'll walk you through it anyway. So since this is up on my local machine here, I'm going to upload the Kubernetes concepts in PDF because I personally work on the Kubernetes project. And I click on Start Assessment, and I don't suspect this to work, but it's going through analysis. Yeah, so we've been stuck on this problem for the last some time now. So that's it for our demo and closing thoughts.
So, a trace?
No.
Oh, no. No. So one of our problems was like trying to figure out how we were going to implement, Dagger into this. So it took us a lot of the time to just set up Dagger in our IDEs and yeah. So like honestly, we're asking for some feedback and any help you all can provide in the Discord. That would be amazing and great to just give us some insight.
Okay. Hey guys, my name is Navneet. My profession, I'm an analyst. So not much have experience with JavaScript or front-end development. But what I built over here is natural language input, SQL query as an output. It references the database that you have uploaded, and as well as the productionized sample SQL queries, as well as the metadata and data schema that you already have. So the way it works is there are 3 agents in place. One.
And could it get bigger? Could this get could you fill the screen?
Okay. Maybe much bigger. One more?
As big as you can go.
No, 200 is like limit.
Still, it's pretty good. Awesome.
Okay, so this architecture, I've been working on this for a good amount of time, and I wanted to use Dagger to see if that can help productionize that application. No?
Yeah, I don't know why.
Okay. Hello. Yeah, but it didn't somehow, unfortunately, it didn't really help, and then I eventually implemented through Docker container in order to productionize and showcase the build over here. So there are 3 agents in place. Once you enter the natural language prompt, first it identifies the intent of what the query is. Based on that, it references something called as knowledge base. This is the input file that you put in to train the model. So basically, they are data dictionaries, metadata, and sample queries. Based on that learning, using OpenAI gateway that I'm using, it generates a SQL. Now, what happens is it hallucinates a lot when generating a SQL. So I've created a second agent, which is a SQL validator. It validates the generated SQL. So basically, the first agent will generate the SQL. Second agent will validate the first agent's work. The third agent that I've created is the evaluator. Evaluator's job is to reference the metadata, which is already been fed, and reference and check the SQL generator. The first agent job to evaluate whether the produced query is right or wrong. So I'm going to go and quickly go into the demo. I was using Dagger, but I was running into errors, so I'm going to close out the screen. This is the full screen. Okay. So basically, let me just type it. Could you? Yeah. So let's say I feed a dummy data over here. So those are not the actual productionized data. So what is the last? Okay, what is the sign?
That size too?
Yes. Thank you. Last month. So once I inputted this information, what is the signed up count last month? So I've created something called as RLHF, which is reinforcement learning by human feedback. So when I inputting the query, it's not even generating the SQL. It's first asking me which tables do you want to use to generate the query. So basically what it is doing is finding out the intent, the signed up count, finding out the regular keywords that has been used in the question. Let's say signed up count, last month, and based on that, it is identifying, going into the knowledge base and finding out which table might have this information. It is assigning a score to it. So now you have an option to select either analytics.users or sales.orders table to generate the query. Let's say we generate, we want to generate the query by using a second table, which is sales.orders. So once you input 2, then it is going to call the OpenAI gateway. All the 3 agents are going to do the job of evaluating, validating, and generating the query, and it's going to produce the result. So this is the OpenAI who has produced the result by using all these 3 agents. Also, I created an evaluation metrics. So the generated query, what was the table relevance of it? Which is I'm having a problem on what is the actual metric that we can count on. So don't count me on that. But other 3 metrics are important. Query complexity, how complex the query is. As the database and the size of the knowledge base gets bigger, the complexity level of the query generation will get much harder. The third metric that I'm evaluating against the generated query is the estimated performance. So this is all about the performance of what has been generated previously, and it is taking that as a benchmark and comparing that to generate that query. So basically the score is using that benchmark and this generated output, evaluating that performance of it. So the third piece over here, which is the human feedback loop, is was this query helpful or not? So it is important for you to give that call back to the agent and say if this was this was useful or not. If it was not useful, that means the next time when we are using second table for sales orders to get the sign up count last month, it is gonna provide the lesser score to it, as well as it is gonna make sure that it gives you a prompt that it is not gonna have the accurate amount of information that you want. So let's say I say no, then it's basically, I'm sorry, it wasn't helpful. We'll use your feedback to improve. So it's basically doing that. So it is learning from your input, and then next time it is gonna give you the more accurate results of it. So yeah, that's my project.
Very cool. Question?
How do you implement the feedback of the user?
How do I implement? What do you mean by that?
The feedback from the user. He just did. I mean, he just took the feedback. No.
Yeah, you write no. How do you code that?
So there's a.
The question is how do you code that so that you can receive that input and feed it back to the
So there's a
LLM?
Yeah. So there's a RLHF component file. Basically, I'm gonna share all the codes on the GitHub repository and share it on the on our shared channel so that everyone can see it. But there's a class that I have, this stored feedback. This is the way where it basically takes out the input that you have provided, and then it learns from it. And so RLHF component Python file is the one where it is saving those information into it.
Cool. So a little bit of memory, a little bit of
It's just
feedback,
adding the memory to it.
little memory and
basically.
feedback. Yeah. Very cool. Thank you so much for sharing that. That's
Sure.
amazing. Can't wait to see that project fleshed out more. Big hand.
All right, so we've been working on a thing called Dagger MCP, which is a new hidden command in Dagger that will basically turn any module into an MCP server. So that allows you to essentially use Dagger to interact with MCP clients. So I don't know, can I ask you how many of you know MCP, what it is for, or what it means? Okay, so good handful of people. So let me start by saying that this here is an example project, a Hello Dagger project. It's basically a node-based project. So let's assume I'm a developer.
on a new team on this node-based project, and I Daggerized it already. So let me show you maybe the, do you see any of this? Maybe, sorry about that. So it's a regular Dagger module that can publish its image, build it, test it, etc. So note here that there's nothing agentic here. It's a regular Dagger module. So maybe you have, maybe you know about Dagger's way to interact with LLMs through dag.llm. Maybe some of you know about Dagger Shell's prompt mode. So there are many ways to interact with LLMs in Dagger. In this case, we want to decouple the way Dagger consumes. You want to decouple the client from the server. Essentially, we want to be able to use any MCP client, not just Dagger. So in this case, we're going to use Goose, but Goose could be replaced by any other MCP client, such as an editor or Claude Code or anything like that. So the first thing I can show you here is setting up Goose session. So in the configuration of Goose, you can tell. Let me show you that maybe. In the configuration of Goose, you can see how I set up Dagger. So it's basically calling the Dagger binary and MCP, and that's pretty much all that's needed to run this demo. Sorry, let me put it big. So here I started a Goose session in this Dagger module. Sorry, can I check my notes real quick? Yeah, so in this example, we're going to basically build the app and ask Goose, ask the LLM through Goose to scan for vulnerabilities in the image. So build the app and scan for vulnerabilities in the image, and give me a report with actionable items. This was not the exact prompt I tested earlier, so bear with me. So here it is using a dependency that I installed on this Dagger module called Trivy, which happens to be doing exactly that, and is calling that module, that method on that module, on the Trivy module. So it's scanning for vulnerabilities, and will give me a nice little table of, hopefully. There you go. So, yeah, kind of worked. So this is the first demo where you can basically show how you can use an LLM that will call any function that's in a Dagger module through MCP. Another demo with the same repo is with using another module dependency called npm. It's our own little toolkit here. Let me show you. I think it was in here. Toolkit npm main.go. And all this does is that it will run a coverage. So here you can see that it's installing the dependencies and then just running vtest coverage on whatever source directory I pass to it. There's a little bit of description. All of that will be taken by the LLM as hints on when to use those functions. All right, so what am I supposed to type in here? Oh yeah, it's actually, yeah, run the test coverage and, oh no, I remember this. Sorry, let me cheat real quick. So run the npm coverage and add a test to increase your coverage of the welcome.view file to 100%. I needed to do a little bit of prompt engineering in some of my tests, so just to be sure I ask it to really, really try. In some of the tests I didn't need to, but just to be sure. So here it found an NPM module, calling the NPM coverage method, and right away starts creating new files. Figured out where the directory is, and hopefully starts doing its thing. At the same time, I'm going to show you that all of this, hopefully, because I don't know if I put my keys. All of this has traces in Dagger Cloud. I believe this is the one being used. And so you see how the LLM is sometimes failing, saying describe is not defined. Well, first of all, it tries. It sees that welcome view coverage is 0%, and it's trying to do 100%. Then it tries again. It does something and it tries again. Here's the first version of the file. Can't see it very well, but this is the first version. Tries again, there's an error. No problem, goes further. Save the results. It stopped. Let me see if it worked. Okay, so did it actually create a new file? And there you go. Here's our new file. And this passed the test, the 100% test. So yeah, this is just a short demo to show how you can use different MCP clients, not just Dagger itself, and still use Dagger for the server side. Here we used it with a module. In the future, we could maybe have it figure out exactly which core APIs to use. And with this, I think I'm going to let Guillaume go further on how to make this even more robust.
You need to plug in.
You need to plug in. Great.
Yeah.
Oh, you want this?
Cool, while you get set up. That's awesome. So it's really cool. What we saw there is you had just a regular old project, right? That original, like the Hello Dagger project. It's just like a Vite node project, it's like no big deal. And then at some point you guys Daggerized it, adding this Dagger module kind of alongside that, so that the project could build itself and publish itself and all this stuff. And then you just handed that to an LLM and said, hey, I had my human building and testing before, but these are just now tools for you. And then the LLM was able to see those tools, use those tools, and perform useful tasks. And then when they added a Trivy security scanner module and an NPM module that knew how to do NPM things, like coverage reports, now this agent, Goose, running as a client, was able to do all that. So very, very cool. So now, Guillaume, where do we go from there?
Yes, so Dagger, with the concept of modules, enables you to give exactly the right thing at the right time to the LLM. An LLM needs some context, it needs some prompt, and it needs tools to do the assignment. It's very hard to always be right on point. That's why, when Tibor was demoing the Trivy and basically I'm a developer, I'm using tooling to do tasks all day long. Like this Trivy module that he used is actually useful as a human to see the vulnerabilities of the image that we publish. And he just gave access to the LLM and saying, hey, I'm having a task, I want to have more feedback on that, use it too. So that's what he did using Goose. The thing is that sometimes these are not reliable. And in order to have more reliability, internally we had to design our own eval system. And we think that if you want to build good agents, you also need to have good evals. These evals can be scary. And so we want to show you that using Dagger and the same concept as modules, it doesn't have to be as scary at all. So here I'm taking away the same context that he was in. I'm in the same project, okay? I vibe coded using what Tibor did. And now I'm trying to see how does it behave upon multiple LLMs, upon multiple clients too. It might be interesting to see that and eval that, because reliability, you need to contain the non-predictiveness of the LLM. So that's a work in progress, but that's an opinionated way of doing evals. So what we think is that you should think of your evals as a series of steps. So it's like a workflow. Here, Tibor, what he did, he had the assignment of checking the vulnerabilities. In order to do that, I had to first publish the Hello Dagger app, then I had to check for vulnerabilities, and then I'm asking him, summarize the results and give me action. I'm not going to go into the details, but we are using some very important concepts in Dagger, which is the environment. This environment regroups the prompt, the context, and the tools available, and we're using that to give context and retrieve context. So for each step of the dev loop of the workflow, we're telling him, hey, try it out, and we're asserting here if it worked or not.
A little more even?
Sorry, it's not big enough. Sorry. So here I'm having like an agentic flow that is 3 steps, as I showed you. The first step is the prompt that I'm planning on giving him. The second thing is actually the context that I'm giving him. I'm saying, hey, on this step, I'm asking you to give me the image ref of the image that you published, and then I'm doing some test assertion on that. Oh, did it actually publish it or not? And then this is being passed to the second step of my eval, which is, oh, using that, check the vulnerabilities. So that's how you do this agentic flow. Let me just do it right away, and we'll see. It's an LLM. We don't know if it works or not, but we need to do a series of steps to assert that it's going to work. Usually, the way we think evals is through thresholds. So we think that we gave the right prompt with the right tooling at the right time because it passes 80% of the time. So that's how you think about these agentic flows.
Do people, who's heard evals in the context of AI apps and stuff? So yeah, it's like some people know, not everyone's heard about it, but yeah, I think you got it exactly right. Guillaume is like thinking about it in terms of like if you've heard of benchmarks, like or tests in general, but think about like, is your agentic application, is it performing the way you want it to, good enough for how you want it based on how you have it configured?
So here we can see, for example, that the LLM managed to actually read the context of the trivia output, so the vulnerabilities, and it's doing actually the last steps, which is the assertion and giving me action items. So the last step, what I want is to actually have like feedback loop. So now he's summarizing, like we can see it right away here. And so the last thing, so usually it's like, it means that actually the eval worked. We're going to see it right away. It's saving the output and giving it back to me. A few more seconds. Yep, success, it worked. So it's rough, it's going to be live soon with less edges, but feel free to join the Discord and ask about that. It's actually very easy to have agentic flows, especially if you made your agent inside Dagger. It doesn't have to be Dagger. What I didn't show you is that at the moment, this eval didn't run inside Dagger, it ran with Goose. So everything, I tested this eval on Goose using Dagger. That's what we just did right away. Yeah, thank you.
I just wanted to say that the next step would be to do some RL on the prompts themselves. So that would allow us to have that loop where you improve the prompts, improve the descriptions of your functions, and with all this framework, that makes it much easier. Thank you.
We will be demoing a lightweight AI agent which is built on PubMed research, which is like a data set built by National Institute of Health. So the idea is simple. Instead of manually searching for research papers, we are letting an agent handle it. So I'll quickly walk you through what we have done using Dagger or Doc. So it's a 2-part system, the architecture. First one is the Python script. The second one is the Dagger. And what the Python script, like, if you give a query, it hits the API and it gives you the result, and the Docker runs behind and it installs the libraries and it runs the code behind, and the environment is all behind the Dagger. Dagger. And you can see.
No, can you make it huge? Can you make it even bigger?
So here is a query. The query I have given is AI in medical heart surgery. So it has given 5 research papers. Let's open the first one.
This is the first research paper. And you can change the queries as well, so I'll quickly do that as well for you. So instead of, yeah, this is the Dagger code that I've written. So it's a very simple one, you can see.
So
You
can,
just give
can
your
you make
query.
that huge for us? No one else can see it.
I can't make it bigger than this, I guess. So does anyone have any query related to medical research maybe? I can take that question. I can ask the agent to do the work. Can anyone give me a question? What do you do with diabetes? Just saved. Terminal. Call the Dagger. So it's mostly useful for the researchers and students who are like planning to do something related to healthcare. So I'll take, sorry.
Oh, nice.
Woo. These are the like we have limited the links to top 5. These are the like top 5 research papers that you can find related to diabetes. So whatever the topic you choose, these are the top 5 links that you will get. So under a minute you will get a research paper of what you're looking for. That's the demo. Thank you.
Okay, so if we built some coding agents tonight with Dagger, we've built a lot of different tools that can help you with developing different parts of your app or doing whatever, but you're probably thinking like, how do I, like I've got this cool new tool, but like I don't want to have to keep running things on my machine when I want to do tasks. Now I just have like a more expensive tool to run locally. So now how do I actually take this and like deploy it to my project so I can have all of these cool agents like doing work on my code base while I'm sleeping or playing video games or whatever. So here in GitHub, I have this demo repo that you can all go look at right now if you want to. It's kpenfound, that's me, /greetings API. And so let's look at this flow of what it looks like when I've actually deployed a bunch of different agents into my GitHub ecosystem, right? So I have this issue and a bunch of this is already like pre-baked so we can see what the agents have done, but we'll actually run one of them live as well and then we'll see if it actually works. So my greetings API is this like Go API that returns greetings and there's like a cool front end for it, very fancy. So I created an issue here and I said, I want a new endpoint in my API where I can actually create new greetings, okay? And then I have a bunch of / commands, and this is how I interact with my agents in GitHub. And I'll show you exactly how this is done because it's actually really simple, and it's not using any crazy GitHub actions. It's just all code that I wrote myself. So I said /develop. So what that does is it signals my developer agent to say, this is an issue that needs to be developed by my agent. And so it picks it up, it does a bunch of work, and then it opens a pull request over here. And so we can see agent Cal, that's my agent, create a pull request that's adding this new feature for my API. And we can see this commit that it pushed up and it added a new endpoint to the API where you can post new greetings. Now that's great, but its first pass at it, I wasn't really happy with the results. It already has like the Dagger functions to call, like the linting and testing and all the things that it needs to write good code, but it still wasn't smart enough to write like the feature how I wanted it to be written. So I have some other things here so I could run this feature and locally and check it out. But the main thing is I wanted to give the agent feedback and say, actually, that new endpoint is cool, but since you're posting new information to the API, it should probably be authenticated. So I said it's another / command here, /agent. This should be authenticated so that only someone with this API key can access it. And so another agent picked this up and said, okay, I looked at the work that's already been done so far. I looked at my original assignment and I'm getting this feedback. And so I was able to push up another commit that actually added a Go function for auth middleware to check that I'm adding this admin key in the headers. And so now I'm like, cool, that looks pretty good. Let's see what like a full code review looks like, because I don't have time to scroll through your code changes and really think about them. So I have another agent that says, okay, I'd say /review, and this agent goes through and has a bunch of criteria that I've worked on to kind of hone in like what I want a good pull request to look like. And this says, okay, it's pretty good, but you know, it really should have new tests for this new stuff that's being added. And here's some other improvements that could be made. But I think this PR is acceptable if we add some new tests. And so I say, okay, please, /agent, please add some new tests. And so it ran, and let's see what it came up with. It added a test for the new function, but I looked at this earlier, and this is going to be our little experiment real quick, in that in adding this new test, it actually deleted our old test, I think. And so I don't think we're testing all the stuff we were testing before, which is too bad. So let's go back and give it some more feedback and say, agent, please don't the tests for the other endpoints. All endpoints should be tested. And we'll click this, and then let's look at what happens when we click this. So it'll kick off, and we're not going to miss any things. It takes a minute because it's LLMs and so on. But if we look at the code real quick for why that /agent actually makes the agent run, and we're going to look at some YAML. I apologize, but it's really simple. I have this like /commands YAML where whenever an issue comment is created in GitHub, I'll bump that up a bit more. We have a bunch of different /commands, and I basically say with all these different jobs, like if this is a pull request and the comment is /agent, then run this Dagger function. If it's a pull request and it's /review, run this other Dagger function. If it's not a pull request and it's /develop, run this other Dagger function. And so it's just 3 different functions, and they actually look a lot like the one from the quick start if you followed that today. So if you look at like .dagger, develop.go, this little develop function looks almost identical to the one in the quick start guide if you followed that. And if you wrote it in Go, other languages it looks fairly similar too. But all these different functions look kind of like this, and they've all got kind of their own prompts that guide them on how to accomplish their task. For example, for the code reviewer, we tell it kind of how to think through the code review process, to think about the intent of the PR and so on. Here's our criteria for what a good PR should be. So anyway, a minute ago we asked the agent, we did /agent, make sure you didn't blow away all the tests. So if you go over to actions, we'll see that this thing's running from our / commands. If I go to Dagger Cloud, we can watch it live happening in real time. So here it is. And I'll blow this up a little bit so we can see it's calling that pull request feedback function. And it says, please don't delete the test, blah, blah. And so we have the function be called, and then we have this trace of like, this is our prompt, our little person emoji. And this prompt we just looked at in GitHub that says, here's your problem solving process. Here's the feedback we were given. Here's the diff so far of the PR. And so it has all this information as well as the tools to actually work with our code base and make the changes. So it says, okay, I need to restore the tests that were deleted in main test.go. Cool. And so it's going to look through all the tools we gave it. It sees that it's able to read files, and so we can actually expand this workspace.read, and it's looking at that test file that it's editing. And so now it's thinking, okay, what should I write? And so it wrote some modifications to this test file. And so we can see what it wrote here, and hopefully that's good. And now it's actually running workspace.check. So this is like our actual test function that runs in CI. And if this passes, then it's going to go back and push those changes back to our pull request. So let's watch this. Looks like it says it passed. And so if we go wait over here, let's see, where was I? Back on our pull request. And it might take a second to push the commit. It pushed it, okay. So push a new commit, and let's see what it did this time. So it added back these 2 different tests. And if we look at the overall diff, hopefully it looks pretty good. And we can merge these changes. So there's our main test, or our main.go, where it's added our middleware and our new endpoint. And then in our test file, we've got all these tests. And it looks like it rewrote them all, which is fine. And we could continue to guide it through if we wanted. And the last agent that we didn't see working here is if I push a PR and the tests fail, because remember the agent itself, it can't make a PR with failing tests because it has those tools and it's enforced to run tests. But me as a dev, I can do whatever the heck I want and I can push broken code. And so if I do that, then we still have agents running in our GitHub that say, oh look, the test failed and here's the fix for it. And so I can say, boom, let me just commit that. And now I'm a happy developer with green test because I didn't need to actually run them myself. And so now this will pass in a few minutes. So yeah, that's what it looks like when you take all those cool little units, and each of them are really simple by themselves, but you make a lot of them and put them out on your infrastructure running in your code base. And now you don't have to run your tests anymore. Yeah, that's it. And this is all on GitHub, so check it out.